So on this next example, it says the Postal Service charges $2 to ship a package up to 5 ounces in weight, and then an additional 20 cents for each additional ounce after 20 ounces. After that, they charge 15 cents for each additional ounce. So now this is a graph of what they're going to charge, right? So the question then is, what is the domain? Well, let's talk about what the domain is. So what is the domain of this relation? Well, the domain is really the possible independent variable values, right? So remember that the domain is associated with the independent variable. And in most cases, it is always going to be x, right? So the domain then is going to focus on the x values. In other words, the cost depends on the weight. The more something weighs, the more it costs. So if the cost is the dependent variable, then our domain is going to focus on what are the possible weights. Well, what's the least a package can weigh? Oops, ran out of space there. What are the possible and then notice that it says it in ounces, right? So when we say what are the possible weights? Well, I mean, you could have something weigh less than an ounce. Could you have something weigh 0 ounces? It depends on how the post office does it, because so this is how we got to figure it out. They're going to charge $2 no matter what. So maybe they have something that weighs something that's so light, it may be like a fraction of an ounce. It's possible. I doubt that it would equal 0, and I'm not sure if the creators of this problem, if the authors of this problem thought this through, but technically the domain is all the possible x's, right? So it's probably greater than 0, but it wouldn't be less than 0, right? So how do I say that? Well, I would say that the domain then would be x is greater than 0. Now that's the answer Mr. Adams would choose, but actually the author of this actual question, they said, well, it'd be greater than or equal to. But when we look at the graph, it doesn't really matter, because if I look, the way the graph is set up, my x value, the lowest x value I have on the graph is 0, and then this arrow indicates that it goes on forever in the x direction. So then the domain, based on the graph, they're going to take this line all the way up to 0. Okay? So the domain, when we look at the domain, we've really got to look from left to right and figure out what all the possible x's are. And what's going to happen is sometimes you're going to get confused and you're going to focus on the y's. No, domain is always going to be the x values, always. Okay? What are the possible x values? And you can think about the situation, or you could look at the graph. If we think about the situation, we wouldn't include 0 because the package has to weigh something. But if you look at the graph, they included 0, so we have to include it too. Okay?